Today we are going to solve a problem on effect of gyroscopic couple and centrifugal couple on a four-wheeler. This four-wheeler is moving on a track such that this track is inclined at an angle theta with the horizontal. Now first I will read what is the given problem. A four-wheel trolley car of total mass 2000 kg running on rails of 1.6 meter gauge rounds a curve of 30 meter radius at 54 km per hour. The track is banked at 8 degree. The wheels have an external diameter of 0.7 meter and each pair with axle has a mass of 200 kg. The radius of gyration for each pair is 0.3 meter. The height of center of gravity of the car above the wheelbase is 1 meter. Determine, allowing the centrifugal force and gyroscopic couple actions, the pressure on each rail. So this was the given question. Let us first understand the given data with the help of diagram. So we will take here the front view of this four-wheeler. Now it is given that mass m, that is mass of this vehicle, that is equal to 2000 kg. Then it is moving with a speed of 54 km per hour. So here this kilometer per hour we have to convert it into standard unit, that is meter per second. So we have to take here 54 multiplied by 1000 divided by 3600. Because in 1 hour there are total number of seconds 3600. So which is equal to 15 meter per second. That is the velocity of this vehicle. Then x is equal to 1.6 meter. Now we know that the distance in between the outer wheels and inner wheels, that is equal to x, and that is given 1.6 meter. So here is the front view of this vehicle. So if we observe, we have to give the numbers to the wheel. That is, here is 1, 2, 3, 4. So these are the numbers to the wheel. So we will consider this wheel number 1 and 2 are the inner wheels, and this wheel 3 and 4 are the outer wheels. So the line joining the inner wheel and outer wheel, that is the line joining wheel number 2 and 3, that is nothing but the distance, that is equal to x. So these are the back side wheels, that is wheel number 1 and 4, and here is also the line joining there. So this line joining this inner wheel and outer wheel is known as the axle. So around that axle the wheel is getting rotated. So we can say that this axle is nothing but the axis of spin that we can consider here. Now it is given that theta is equal to 8 degrees. So the track on which this wheel is moving is inclined with this horizontal and at an angle theta, and that is equal to 8 degree. Then r is equal to 30 meter. Now while this vehicle is moving with constant velocity v, it is getting turning. So this turning process is taking place with that road, or we can say track. So this track having radius of curvature, that is capital R, is equal to 30 meter. And from that radius of curvature there is the center for that radius, and from that center there is the axis of precession. So we know that. So please refer my previous video, that is the theory on effect of gyroscopic couple and centrifugal couple on four-wheeler, and the link is also given in the description box. So you will get the detailed theory there. So now we will consider, that is as per given data, this R, because the vehicle is turning and that radius of curvature of the road is nothing but capital R, 30 meter. Then the diameter of the wheel is given. So this wheel is having particular diameter 0.7 meter. So here we will use the suffix w. So from that, here radius of that wheel 0.35 meter. Then this axle. So the weight of axle with these wheels, that is, we can say that weight of the axle connecting to the wheel 2 and 3. So this total weight is nothing but m1, 200 kilogram. Then radius of gyration. So wheel is rotating about some radius. So that radius of gyration is also given, that is 0.3 meter. And then h. So what is the distance h? So we know that it is the distance between the center of gravity of that vehicle to the surface of road. So here is the surface of road and we have to take the distance. So here is the center of gravity. So this vertical distance is nothing but h. So this h is given, that is 1 meter. Now this is the given data and here is the diagram. So we have to draw here track inclined at an angle theta. Then we have to draw here 4 wheels and this is the front view. So why we are taking front view? Because on the front view we can clearly see where is the exact location of the center of gravity. Then we also know the weight. So weight of the vehicle will act in vertically downward direction. So we have to take here one line because this vehicle is inclined, but we have to take here W in vertically downward direction. So straight vertical line that is perpendicular to this horizontal line, we have to take here the weight W. So this is the direction that is in the downward direction. Now we will consider the vehicle is turning in this direction, that is turn is taking place. So centrifugal force that will act in radially outward direction. So we have to show line parallel to this horizontal line. So along that line there is the centrifugal force that is acting. So here this is the diagram. Now we know that this vehicle is moving on the inclined road. So we have to resolve these forces. That is this force, that is weight W, that is in vertically downward direction, and this centrifugal force. So how to resolve that force? So for that we have to draw the horizontal component and vertical component for this weight W and for this centrifugal force. So if we observe for the weight W, this is the line perpendicular to this horizontal line. Now we have to take two components in such a way that one component is parallel to this track and other component is perpendicular to the track. So remember we have to draw. So for weight W, how I can write here? So for this track I will take one parallel line. And for this track I will take one perpendicular line. So this is the starting point of weight W. So from this track I will take here one perpendicular line. So here this is one component and here is the other component. Now we have to take here what is the exact value. So for that we have to take where is the location of angle theta. So this is important point. So I will draw here rough diagram for understanding purpose. So the angle theta is given this horizontal line and this inclined line. So if we observe, here is the horizontal line and here is the inclined line, angle theta is given. Now this weight W is perpendicular to this. So I will draw here one line that is perpendicular to this horizontal line. Now if I draw one perpendicular line to this inclined line, then that is the point, at the point of intersection in between the perpendicular lines will give us the same angle theta. So here this is the one line that is perpendicular to the horizontal line, and if I draw here one line perpendicular to this inclined line, then the angle in between these two lines will give us the angle theta. So here will be also angle theta. So if we observe this diagram, this vertical line is nothing but W, and for this inclined line this is the line which is perpendicular. So I will show here this will be angle theta. So in this way we can say that what is the value of this component, that is it is nearby to angle theta. So I will say W cos of theta, and this is away from the angle theta. So I will say W sin of theta. So it is getting completed. Now we will move for the next. So again we have to resolve this FC. So FC is horizontal, that is parallel to this horizontal line. So again we have to resolve into two components, one parallel to this track and other perpendicular to this track. So parallel to this track we have to take. So this is the point of origin of FC, that is the point G. and perpendicular here same line is there, so I will show here. Now again we have to decide the value. So if we observe, here is the horizontal line. So this is line parallel to this FC, and again this is the inclined line. So this is line parallel to this line. So these two lines are parallel to each other, and this FC and this horizontal line parallel to each other. So these two lines are parallel, so angle will be same, that is theta. Now it is easy for us to give the value. So this component is nearby to theta, so I will say FC cos of theta, and this component is away from theta, FC sin of theta. So in this way it is getting completed, that is the resolution is getting completed. Now we will move for the next step. So what is the first step? So here if we observe, this is the inner wheel and these two are the outer wheels. So we will take here the reaction. So reaction is taking place. Why? Because this weight W is acting in the downward direction, and this weight is carried by these four wheels, 1, 2, 3, 4, and these four wheels are in contact with the road surface. So reaction is taking place in the opposite direction, but here the road is inclined, so we have to take the reaction that is perpendicular to this inclined road. So I will take here reaction for the inner wheels, that is the reaction RA, and which is in the perpendicular direction to this inclined road. So I will show here. This is RA. Now in the same way, these are the outer wheels, and here also the reaction is taking place, that is in the perpendicular direction to the road. So road is inclined, that's why we have to show that, and here is the RB. So these are the reactions which are perpendicular to this inclined road. Now we have to first find out what is the value of these reaction forces RA and RB. So how to find out? So we will take here the first step, that is summation of all the forces perpendicular to track. So we know that summation of all the forces perpendicular to track, which is equal to 0. So we have to take this. So for that, if we observe, we have to take all the perpendicular forces. But here forces perpendicular to track. So here we have to take the forces that are, this is the track, and we have to consider all the forces perpendicular to this track. So if we observe by just observation, here RA is perpendicular to track, RB is perpendicular to track, W cos theta perpendicular to track, FC sin theta perpendicular to track. So we have to take the summation. So I will take here, now if we observe, these forces are in the upward direction and downward direction. So I will take the same direction force on the one side, and this other side there will opposite direction of force. So I will take here RA plus RB is equal to, because both are in the upward direction, so is equal to here W cos theta plus FC sin of theta. Now this point is important. So we don't know what is the exact value of FC, that is centrifugal force, and what is the value of W. Now it is not given. So how to calculate W? W means what? M into G. So I will write here mg cos of. So a theta means 8 degree plus FC. So what is this FC? So FC, that is, we know centrifugal force is equal to M into V square divided by capital R. So we know what is the value of M, what is the value of V, and what is the value of R into sine of 8 degree. So again we will put the value. So we can take here M as a common term. So M is 2000 in the bracket 9.81 cos of 8 plus V square, that is 15 square by R, that is 30 sine of 8. So here after calculation the answer is 21,580 Newton. Now what is the next step? Here we have to take the moments about B. So we have to consider all the forces to take the moment at this point B. So we know that moment is the force multiplied by the perpendicular distance. So we will take the summation of all the moments about B, which is equal to 0. So I will take here summation of moment of all the forces about B is equal to 0. So we will first start from here. So RA. Now we have to consider whether this moment is in clockwise direction or anti-clockwise direction. So if we take for the clockwise direction positive sign, then we have to take for the anti-clockwise direction negative sign. So if we take here the B as a center and move the compass in the direction of RA, then here is the clockwise direction. So we have to take this RA multiplied by the perpendicular distance, that is x. So I will take here RA multiplied by x. Then we will take the second force. So second force, if we take here, that is W sin theta. So here B as a center and we will move the compass in the direction of W sin theta. So it is in the anti-clockwise direction, and what is the perpendicular distance in between this point B and this W sin theta? So point B is at this point of contact. So here this perpendicular distance is h. So I will take here minus W sin theta into h. Then again I will take the next force, that is Fc cos theta. So Fc cos theta, again I will take B as a center and move the compass. So clockwise direction. So I will take plus Fc cos theta and perpendicular distance is h, plus Fc cos of theta multiplied by h. Then again if we observe here W cos theta and Fc sin theta. So both the forces in the same direction. So if I take the compass and move the compass in the direction that is the downward direction, then there is the anti-clockwise direction. So I will take here the negative sign. So what is the perpendicular distance in between this force and this point P? So here is this perpendicular distance. So this perpendicular distance, that is, this is the point B, point G, and this is the middle point of this total horizontal distance. So for this point G, if we consider this is the middle point, so in the same way it is the middle point in between these two wheels also, that is the wheel number 2 and 3, and for this total distance in between two wheels is x. So what is the distance in between this point B and this point G? That is equal to x by 2. So we have to take here the distance x by 2. So if I take here this distance, that is minus W cos theta. So I will take here minus W cos theta into perpendicular distance x by 2 minus Fc sin of theta into perpendicular distance x by 2. So which is equal to 0. So if we take all the forces on the right hand side and RA on the one side, then we will rewrite this equation. So how to write? So I will take this x also on the right hand side. So it will divide for each term with x. So I will take here, therefore RA is equal to. So all this term we have to shift towards right hand side. So this minus sign will become plus. So W sin theta multiplied by h by x. Then here plus sign will become minus. Minus Fc cos of theta into h by x. So here minus sign will become plus. Plus W cos of theta. So this x and x is getting cancelled. Multiplied by 1 by 2. And here plus Fc sin of theta multiplied by half. So if we put all the values, so how to put all the values? So W is equal to mg, that we have to put. Then this Fc. So Fc means what? mv square by r. So we have to take m is equal to 2000, v is equal to 15 and r is equal to 30. So in this way we can calculate here W, Fc. H is equal to, that we have to take h is given 1 meter. Then x is also given 1.6 meter. So all the values are known. Theta is equal to 80. So all the values are known. So if we put all the values, then we will get this one unknown term, that is Ra. After calculation, value of Ra is equal to 3182 Newton. So we know that what is the value of Ra plus Rb? 21,518 Newton, and that's why Rb is equal to this Ra plus Rb minus Ra, which is equal to 18,336 Newton. Now we will move for the calculation of gyroscopic couple. Now here the axis of about which the wheels are rotating is inclined, and that's why we have to use the different formula, because if we observe there are three axes and which are perpendicular to each other, that is x, y and z. So if we consider here is the x axis, that is the horizontal, and about which there is the axis of spin, but in this case the axis of spin is inclined, because the axis of spin here, the axle joining to the wheels, that is wheel number 2 and 3, and which is inclined to this horizontal. And axis of precession is the vertical line passing through the center of the curvature of the road. So here is the axis of precession along the y-axis, and here the axis, third axis is z, which is the axis of gyroscopic couple. So first we will find out what is the value about this x-axis. Now we will draw here one diagram. So this is the horizontal line. So I will take here one horizontal line, and which is nothing but x-axis. And at the about this horizontal line there is the angle theta, and here along this inclined angle theta there is the axis of spin. So here these two lines, that is the line joining the wheel 2 and 3 and this inclined line, both are parallel to each other, and this is nothing but the axis of spin. So what is the value, angular velocity of the axis of spin? So we will say that the angular velocity of the axis of spin is nothing but the angular velocity of the wheel, that is omega w, because about this axis there is the wheel and that is getting rotated. And how to calculate this? Omega w is equal to v by rw. So velocity of the vehicle, that is linear velocity, is known and that is given in the question, and rw, that is also given, that is the radius of this wheel, is also given. So if we calculate this, we will get here 42.86 rad per second. So this omega w value is 42.86. But in formula we require these three axes. So here what is the value of this axis? So this is the value of omega w. Here is the angle theta, and this is the component nearby to angle theta. So we can say that its value is omega w cos of theta. So instead of omega w we have to use here omega w cos of theta. So remember that in every case where this axis of spin is inclined, then we have to use the value taking into consideration this angle theta. So this is applicable for every case where the axis of spin is inclined. Now the remaining formula, that is gyroscopic couple, that is equal to I omega omega p. So in this case we have to take I for wheel, that is the mass moment of inertia for the wheel, then omega, instead of omega w we have to take omega w cos of theta, and omega p. So omega p, that is nothing but v by r. So we know that formula. So velocity v divided by radius of curvature of the road, so which is equal to 0.5 rad per second. Now what is the mass moment of inertia of the wheel? So if we observe the question here, the mass of this axle with these two wheels is given, and that is equal to 200 kilogram, and the radius of gyration is also given. So suppose we consider this, that is the mass of this axle with these two wheels and the radius of gyration, then how to calculate the mass moment of inertia? That is mk square. So here instead of m we will use here the mass m1 as a notation for this mass. So m1 k square, that is 200 into 0.3 square, then omega w cos of theta, so omega w 42.86 cos of 8 into omega p, that is 0.5. So when we calculate this we will get here 382 Newton meter. So this is the value of gyroscopic couple. So what is its effect on this wheel or on this vehicle? So the effect of this gyroscopic couple is to overturn this vehicle about this point P or about this outer wheels. That means because of this gyroscopic couple, it will lift the inner wheels, that is wheel number 1 and 2 are getting lifted, and it will push the outer wheels, that is wheel number 3 and 4 that are getting pushed. That is the action is in the downward direction, and here this action is in the upward direction. Now I have to show the reaction. So reaction is taking place by the road surface on the wheel, and that reaction I will say R gyro. So for this inner wheel, I will show the reaction is in the opposite direction, that is in the downward direction. So this reaction is nothing but R gyro, that is in the downward direction. And here this reaction, that is action is taking place in the downward direction. So reaction is taking place in the opposite direction, that is in the upward direction. So this is the R gyro. Now we will consider P is the magnitude of reaction force at the pair of outer wheel or inner wheel. So here this is the pair of inner wheel, that is wheel 1, 2, and here outer wheel, that is 3, 4. So we will consider P is the magnitude of the reaction force. So we have already shown here reaction force due to this couple is R gyro. So here this is the R gyro, which is in the downward direction for this inner wheel, and for the outer wheel R gyro, which is in the upward direction. So this R gyro is nothing but P. So how to calculate P? So this is the reaction due to couple or gyroscopic couple. So we will take this couple divided by distance in between these two wheels. So this distance is x. So 382 divided by 1.6, which is equal to 238.75 Newton. That is the value of P. Now this value of P, that is nothing but R gyro. So now we have to find out what is the total pressure on inner wheel. So this total pressure on inner wheel, if we observe, this R gyro is in the downward direction, that is P is in the downward direction and RA is in the upward direction. So both are in the opposite direction, so we have to use here subtraction, that is RA minus P, that is 3182 minus 238.75, which is equal to 2943.25 Newton. So this is the total pressure on the inner wheel. Now if we observe what is the direction of this pressure or the direction of this reaction force. So this RA is in the upward direction, and here this is having more magnitude, that is RA. So we can say this total force will be in the reaction force will also be in the upward direction. And then the total pressure on the outer wheel. So both are in the upward direction. So we have to add this. That is 18,000. That is RB plus P. So 18,336 plus 238.75, which is equal to 18,574.75 Newton. So here also both the forces is in the upward direction. So reaction force we have to show in the upward direction.